Nice. So let's get started without any further ado. In the last class, I think we have covered up to the different categories of IP addresses, class A, class B, class C, class D, and class E. Today, we'll be talking about some important protocols. So firstly, let me cover what subnet mask is. So the subnet mask value is basically for the computer or the information system to understand which IP belongs to which category. Now, when I type IP config here in my terminal, you see the private IP address here, 192.168.0.5. And under that, you see there's something called subnet mask. Okay. What is the subnet mask? Okay. This is for the computer to identify this IP's classification. Okay. It's a very simple concept. Wherever there's a network portion, you assign the values 1 there, and wherever there's a host portion, you assign the value zeros. Okay. So the class, again, we can identify classes from the network and host portions, but the computer always identifies them with these values ones and zeros. Okay. So to determine which IP belongs to which class, oh, yeah, okay. So to determine which IP belongs to which class, the computer assigns the network portion bits with the value of 1 and the host portion bits with the value of zeros. So for class A, with one network portion and three host portions, that's 255,000. So all ones is 255 and all zeros is simply 0 when you convert it from binary to decimal. So for class A with one network portion and three host portions, subnet mask is 255,000. For class B with two network portions and two host portions, subnet mask is 255,255,000. And for class C with three network portions and one host portion, subnet mask is 255,255,255,0. And if you go back to the command prompt, you can notice here what I get is 192.168.0.5. This is a class C IP address. Since it is class C, the subnet mask is 255.255.255.0. Okay. So from the subnet mask, the computer gets to know, okay, this is class C, so I can only communicate with 255 IPs in my network. And from that 255 IPs, it gets to know the range as well, from 0.1 to 0.255. Those are the only list of IPs I can communicate with, not more than that. Okay. And default gateway is just a fancy name given to your Wi-Fi router, guys. The router in your home network is also called the default gateway. It is acting as a gateway between the private network and the public network. If you remember this diagram from our earlier sessions, when any of these devices wants to communicate with the internet, they always have to send the packet to the Wi-Fi router here first. And then the router transmits the data across the network. So from the private network to the public network, or vice versa, whenever data needs to flow across these two different networks, it always passes through this gateway. Okay. Hence, it is called the default gateway, which is your router. The first IP in the network is always assigned to the default gateway. Okay, so that's what the default gateway means in the command prompt. Okay, now the main question is, how are these IP addresses being assigned? As mentioned in the last class, private IPs are completely in your control, the user's control itself. So to assign the private IP, there are two methods. One, you can manually assign it yourself from the control panel, or two, you can get it automatically from something called a DHCP server. We're going to discuss both the methods now. Okay. So firstly, if you want to assign an IP manually from the control panel, this is the exact procedure to do so. First, you would open up the control panel, then you go to network and internet settings, then network and sharing center, then change adapter settings, right click on the adapter, go to the properties, IPv4 properties, and assign the IP address. Seems a bit complex, but pretty easy to follow. So if I do this practically, go to your control panel. In the control panel, go to network and internet settings, go to network and sharing center, click on change adapter settings. On the left, you see this change adapter settings. And here you can right click on whichever adapter you want to change the IP address for. Go to the properties, select IPv4 Internet Protocol version 4 properties. And now you see these are the two methods. One, you can get it automatically from a DHCP server, or two, you can assign it manually yourself. So if I want to assign my own IP, I can specify the IP here, 192.168.0.100. Since this is class C, subnet mask is 255.255.255.0. It gets automatically assigned. If I give a class B IP, let's say if I give something like 172.16.0.10. This is class B. So now subnet mask is 255.255.0.0. And if I give class A something like, let's say, 10.0.0.10, you get 255.0.0.0. That is class A. So subnet mask depends on the class that you assign. So if I go back to 192.168.0.100, you see subnet mask is 255.255.255.0. And then you need to assign the default gateway, which is your router's IP, first IP in the network. And along with that, you also need to assign the DNS server addresses. Don't worry what a DNS server is. I'll explain that shortly. Okay. But just in case, if you don't know what to enter here, you can always go to your browser, the web browser, and here you can do a quick search. Google DNS server IP, and this will provide you two IP addresses. One is 8.8.8.8, and the other one is 8.8.4.4. And you can assign any one of those addresses over here. So you can either type 8.8.8.8 or 8.8.4.4, and anything would work. Okay. As soon as I click on OK, now my system's IP address will change from the existing one to the one that I've assigned here. Okay. But I would not want to do that now because I would lose my Zoom meeting connection. We would get disconnected from the meeting since I will be changing my IP. Okay. So I don't want to disconnect right now. But again, later on, I would recommend you trying this out. No harm in that, guys. If something goes wrong, always just select the first option and you'll get your original, again, IP address and the internet connection back. Okay. So now the main question is, when do we use either of these methods? When would you assign it manually and when would you prefer the DHCP server? So manually, again, when you want to assign an IP, it is usually done for smaller networks. If it's a class C network, like with 10, 20 devices, it's pretty easy for the network administrator to go to every single system and assign an IP this way. Okay. 10, 20, 30 devices, well and good, manageable, but yeah, still possible. But if it's a larger network, like let's say if you have 250 devices, 300 devices, 500 devices in a network, it's not that easy to manage such a large network. You can't go to every single system and assign an IP manually. And if some device goes down, then that IP is wasted. So that IP, you have to go and check which device that is, and you have to remove that IP, assign that IP to another device. That's quite hectic. So that's why for easy management of these IP addresses, we have something called a DHCP server, which is this one click of a button, automatically my system gets a unique IP in the network. So that is, again, as simple as it can get. But what is this DHCP server and how is it assigning that IP address? So in our organizations or in our home networks as well, our Wi-Fi router itself acts as a DHCP server. So if you had a question, in my home network, where do I have the DHCP server? If you open up your command prompt and if you run this command, ipconfig/all for extra information on each interface, you can see I have a DHCP server in my network, and that DHCP server gets the same IP as my default gateway, which indicates my Wi-Fi router and the DHCP server are the same device. Okay. Now DHCP stands for Dynamic Host Configuration Protocol. Okay. So from the name itself, you can figure out what it is doing. It is to dynamically or automatically configure an internet protocol address to every host in the network. Dynamic Host Configuration Protocol. Okay. Now, that configuration of IP addresses automatically happens with something called the DORA process. Okay, so your DHCP server has a pool of IP addresses. So if this is my Wi-Fi router, it gets the first IP. Okay, and other than that IP, every other IP is mentioned in a pool. And from that pool, using the DORA process, it assigns each unique system a unique IP address. And once it is assigned to that device, that IP is removed from the pool. Okay, and the only remaining other IPs will be mentioned in the pool after that. Okay, but what is this DORA process? Okay, so whenever you connect a new device in the network, guys, that device starts broadcasting a signal. That signal is called the discover packet. So how does it broadcast it? If you remember, I've mentioned in the earlier sessions, there are two IPs. There's something called the network ID and the broadcast ID. So if I write it down here, so if I have the entire range here, let's say, so if I have the IP 192.168.0.1, 192.168.0.2, oh, numlock is off. Yeah, 192.168.0.3, This goes on all the way up to 192.168.0.254 and 255. Okay. Now before all this, there's also one more IP, 192.168.0.0. Okay. But these two IPs are never used in a network, guys. This IP and this IP are never used. This IP, this IP is called network ID, and this IP here is called the broadcast ID. So the only usable IPs you would have now in a network are these. So these are the only usable IPs in a network. Okay. Network ID is to assign or give the identity for the entire network. And broadcast ID is something which is used to broadcast a signal. What I mean by broadcasting is if you send a packet to this IP, it is sent to every other IP in the network. Okay, in this entire network. That packet now. So if you send a packet to this specific IP, okay, sorry, it is sent to every single IP in this network. Okay, that's what broadcasting means. One to all. Okay. So when you connect a new device in the network, the first thing it does is it sends a broadcast signal. It sends a packet to the 0.255 IP. So it goes to every single device and it also reaches the DHCP server. This packet is to figure out who the DHCP server is. It is asking every system in the network who the DHCP server is. So when it reaches the other devices which are not the DHCP server, they just drop the packet. They don't respond to it. But when it reaches the DHCP server, that server responds back with an offer. It says, hi, I'm the DHCP server in this network. You have reached out to me and I can observe that you don't have an IP. So I can offer you an IP from my pool. Okay. So whichever IP is used, that IP is not available in the pool anymore. So 0.2 is used, 3 is used, 4 is used. Okay. So the next available IP is 5. So it offers that IP. Okay. For that offer, your device says, oh, thanks for offering me this IP. I would request, okay, it sends a request now saying, do not assign this to anybody else. I want you to reserve this IP for my system. Okay. And for that request, your DHCP server sends an acknowledgement. It says, okay, I acknowledge that request. This is my confirmation. And now I assign this IP to you. And once it is assigned, it is removed from the pool again. It doesn't exist in the pool anymore. Okay. So this is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And I'm pretty sure you must have observed this at least once in your life. Whenever you connect an Android phone to the Wi-Fi network, so when you, again, when you connect it for the first time, when you click on connect after entering the password, you see a message obtaining IP address. I'm not sure how many of you have ever observed that, but there's a message called obtaining IP address as soon as you click on connect after you enter the correct password. So that message displaying obtaining IP address is where the DORA process happens. After the DORA is done, once your system gets an IP, then it shows connected. Okay. So in that short span, like 1 or 2 seconds, DORA happens. As soon as that happens, and once an IP is assigned, then it shows connected after that. Okay. So this is the DORA process. And in this method, you don't have to worry about assigning any IP to any system. Automatically, your device, once it's selected on that option, obtain an IP address automatically, it starts broadcasting the discover signal. Once it finds the DHCP server, it performs the DORA and gets an IP automatically. Okay. If I show you this DHCP protocol in my router here, I can log into my Wi-Fi router. What was the password? I keep forgetting my password. Okay. As you can see, if I go to my LAN settings, my TP-Link router itself is acting as a DHCP server. It's getting the first IP, and this is the pool 0.2 to 199. And from this pool, these are all the IPs assigned to each system. 0.2 is assigned, 3 is assigned, 4 is assigned, 5 is assigned. And there's something called a lease time also. After the lease time, this IP should not be assigned permanently. If the device is not available, that IP should go back to the DHCP server. So after the lease time, it'll perform the DORA again and it'll check if the device is available or not. If it is available, the IP stays. If it is not available, that IP goes back to the DHCP server. It can be assigned to the next device in the network. Okay. So in this way, IPs are not wasted as well. In the manual method, yeah, someone was asking a
Sure.
question.
Just one question. So actually, the packet will be sent from our device, right? To
Uh-huh.
the so it is through Wi-Fi only, right?
Okay, yeah, Wi-Fi itself.
Okay.
Yeah, because I'm connected in the Wi-Fi router. So if it is a wireless, it can happen through the wired network as well. So if you have a switch in the network, okay, and that switch is connected to a Wi-Fi router, and then through from the switch you can pull up LAN cables and connect to every device in the network. In that case also, if you're selected on the option obtain IP address automatically through the LAN cables, the DORA process happens. Doesn't matter if it is wired or wireless, same process occurs. So is that clear? Hello.
Yes.
Right. So that's what DHCP is, guys. Any questions or doubts up to this point? Others?
So just one ask, like if any of the new client is getting attached, again the DORA process repeats.
Yeah, for every new device connected, DORA will happen for that unique host. Not for
O-
all the devices. Only the new device which is connected will perform the DORA. Okay.
Okay,
So,
so you mean like just now if I connect my laptop to the Wi-Fi router, it will assign some IP address, and
right.
after few hours after lease time over, if I reconnect the laptop again, so I will get the same IP or the different IP will get assigned.
Depends on the IP's availability. So
Okay.
in that lease time, if it's within the lease time, if you
Hmm.
connect back, you get the same IP. After the
Okay.
lease time is done, if your device is not available, and in that gap, if any other device is connected to the network, that device might get that old IP, which went back to the DHCP server pool. Okay. If
Got it.
there's no other new connections, if it's your same device connecting in that same sequence, then you get the same IP again.
Got it. Thank you, sir.
Depends on the other device's availability after the lease time. Okay. Within the lease time, no matter how many times you disconnect and connect back, you get the same IP. After the lease time, depends on if any other device got connected in between. Okay. So yeah. Any other questions or doubts?
Just one more doubt, sir. It's maybe a silly one. So why every host we used to connect 192.168.0.1 to the Wi-Fi router? Is it a common way of connecting the router?
In our home networks, when you set up the Wi-Fi connection, usually your ISP guy sets it up. And since it's a small home network, he always gives class C. Okay. In organizations, you might see other classes also, class B or class A. If you want, you can change it in your home network as well. But it's a good practice to assign the class according to the network size. And since our home networks are small networks, they go class C itself, which is 192.168 dot any IP,
Got it.
right? Moving on. So after DHCP, we have one more server called DNS server. Let's talk about that. What is a DNS server and why do we need a DNS server? So to understand DNS servers, let's talk about, again, to understand it easily, let's try understanding how your phones have a contact application, what the purpose of that is. Right? Now, everyone owns a phone, Android or iPhone, irrespective of the make and model. You have an application called contacts in it. Main purpose of that phone book or the contacts app is to link a contact name to a contact number, right? We humans are terrible at remembering long series of numbers. So if you get my contact number, the first thing you do is you save it. Okay. Next time when you want to make a call or you want to send a text, you search by the name. Okay. And you initiate the call. Now, when the call is initiated, guys, it is not initiated on a contact name. The call is initiated from your 10-digit number to my 10-digit number. The number is what the connections happen on. Okay. Name is only for you to recognize who that number belongs to. Okay. It is only for your remembrance or your recognition. Okay. Similarly, when you go to a browser and in the browser, when you search for a website or a domain like google.com, your browser does not understand this language, google.com. What it actually needs to connect to Google is the public IP of Google. So this google.com website is hosted on a web server, and that web server has a public IP to it. Okay. What your browser actually needs is that public IP. Unless and until it knows what the public IP for Google is, it cannot connect to that. And that public IP information is stored on the internet's phone book or internet's contact application, which is the DNS server. Okay. So a DNS server is a server with a huge list of records. These are usually called as host records. Okay. So basically it'll have a domain name, and to that domain name, you'll have an IP address interlinked. Okay. Google.com stored on so and so IP. Bing.com stored on so and so IP. YouTube.com stored on a server with so and so IP. Show.com stored on a server with so and so IP. Okay. So it has an interlinking of every single domain name with its correlating web server's public IP. Okay. So when you search for a domain like google.com, that request first goes to the ISP. ISP will have their DNS servers, and in that DNS server, it knows, okay, google.com is linked on so-and-so IP. And with that IP, it reaches the exact domain. Okay. If there are no DNS servers, you would have to remember the domain, sorry, you would have to remember the public IP of every single website. And that's not practically possible. So DNS server acts like the internet's phone book, translating human readable domain names into IP addresses. When you type a URL in your browser, DNS server resolves that domain name to the corresponding IP, and it allows your device to connect to the intended web server. If I show you a practical example for this, if I open up my command prompt, I can run a command called ping here. Ping is a command to check for connectivity. It sends something called ICMP packets, Internet Control Messaging Protocol packets. These are packets of 64 bytes or 32 bytes, okay, to just check for a response, okay. So your device will send some packets and it waits for a response according to that protocol. So when I type ping google.com, you can see my system is sending 32 byte packets here, and it is getting a reply back from Google. But if you notice the reply here, I'm getting it from a certain IP address, 142, 250, 77, 132. My system sent 4 packets. It received 4 packets in return, and there was loss of 0 packets, which means everything is perfectly fine with the connection. Okay. But if I copy this IP now, if I go to my browser, and in my browser, if I paste that IP here, carefully observe what happens. So if I copy paste that IP and if I hit enter, you see, I get google.com. So that was the actual IP for Google server. But we don't have to remember this IP anymore because your website, again, sorry, your browser, when it is trying to connect to Google, internally it will convert that domain to that exact IP. Okay. And that happens due to a DNS server. So it contacts a DNS server. From that DNS server, it gets this IP. And with that IP, it shows the same exact domain, google.com. Okay. So that is what a DNS server does, linking a domain name to its human readable, human readable domain name to its IP address number. Okay. It's the contact book for the internet, I would say. Okay. As simple as that. Any questions? Any doubts up to this point?
Actually, for DNS server also someone need to inform, right? Means this Google, this IP address. So is there any process like DORA? Means is there any process that means in DHCP we
No,
have DORA
nothing
process to
like that. Your ISPs will be informing that. So every time you register a domain, that again, if you're registering with websites like GoDaddy, BigRock, and etc., those DNRs, they are called as domain name registrars. So when you register a domain, they'll assign an IP, and that IP is circulated by the DNRs from one DNS server to the other DNS servers. Okay, so it's the responsibility of the organization hosting the website. Okay, so GoDaddy, BigRock, Hostinger, all of these companies have their DNS servers. And from their DNS servers, it is again sent to those records are duplicated across multiple other DNS servers. Okay. So your whole internet is basically a huge connection of these contact book servers. Okay. There are millions and millions of DNS servers all across the world. And these servers will share information with each other one by one. Okay. So if your closest DNS server doesn't have the information, it will contact the next DNS server. It will contact the next DNS server. And from somewhere, from one of the DNS servers, it gets that information and then it comes back to your system. So it's a huge web of DNS servers, or again, these contact servers all around the world. So, hello? Super,
Yeah, got it, sure.
right. Any other questions, guys? Any other doubts up to this point? Lokesh, Anurag, Nikhil, Srinivas, Vasif, Subbu.
No, sir, all good.
Right. Last concept for today, let's talk about special IPs. So along with your public and private IPs, there are two other special IP categories, guys. One of them is called as loopback IP, and the other one is called as a PIPA IP. Now, please note, these are neither public IPs nor private IPs. They are not used for communication or connections. They're only used for troubleshooting. Okay. So loopback IP range starts from the number 127.0.0.0 to 127.255.255.255. So any IP starting with 127 is a loopback IP. And this loopback IP is not for connection. You cannot again try to use this IP to connect to other systems. It is only for your internal NIC chip testing. I think I've shown you what an NIC card looks like the other day. So if you just go to Google and search for NIC card, This is what an NIC card looks like. So on your system, you have this chip. Okay. So if you're using a laptop or a computer or a desktop, whatever it be, you'll have an Ethernet port. Even if you don't have an Ethernet port, there'll be this chip. Okay. But if you do have an Ethernet port, this Ethernet port is placed on this NIC chip. Okay. And this chip is responsible for all network communications because all the networking physical components for your network interfaces are placed on this one single chip. Okay. Your Ethernet port, your Wi-Fi chip, your Bluetooth interface chip, all the networking components are placed on this one single chip itself. And if this chip malfunctions, your system will not get an IP address. If it doesn't get an IP address, it cannot communicate with other devices. Okay. And to verify if this chip is working or not, you have the loopback IP. If you open up your command prompt, and in the command prompt, if you ping to this loopback IP, it's basically you pinging to your own chip, the NIC chip. Okay. And you can see I'm getting a reply back here. It means I'm trying to ping or tell hello to my own device and I'm getting a reply back. Hence the name it's called as loopback. You're trying to loop a connection back to your own device. Okay. So it's like you telling hi to yourself and replying back to that hi. There's a loop there. Okay. So and again you can ping any device here. Ping 127. You can give any number after that. 255, 250, 123, anything. Okay. And you get the same response. So the entire 127 dot range is assigned to loopback itself to check for your internal testing. Okay, if your NIC chip is responding back or not. Okay, ping to any of these IPs from the 127 dot range and it'll ping to your NIC card itself. If you're getting a response back, it means the NIC card is functioning properly. If you don't get a response, you have to replace that NIC card or get it repaired. Okay. And after that, there's the APIPA IP, automatic private IP assigned addresses. These range from the number 169.254.00 to 169.254.255.255. So any IP starting with 169.254 is an APIPA IP. Okay. And this is a special IP assigned to your device by the operating system, whether it be the Windows operating system or the Linux operating system or the Mac operating system. Okay. The operating systems will assign this IP in a special case scenario. That is, when your device is unable to retrieve an IP from any other source, it gets the APIPA IP. So if your IP is, sorry, if your device is not getting an IP manually from the network admin, if you have not assigned it manually, and if it is not getting it neither from the DHCP server, so if your DHCP server is malfunctioning, if your Wi-Fi router is down, then your device's interfaces will get the APIPA IP in some cases. Okay. So this APIPA is to indicate that something is wrong in the network and your device is not getting an IP from other sources. That's why the operating system itself is assigning an automatic private IP. Okay, that's called the APIPA IP. So you purchase a new device, your interface usually get the APIPA IP, 169.254 something something. Okay. So that is basically the automatic IP assigned by the OS. Okay. This is also commonly seen after the lease time. So after the lease time has expired, your device gets the automatic IP, APIPA IP. Okay. And if you connect back to your Wi-Fi router, then you get the Wi-Fi router's private IP. Okay. So those are the two special IPs, guys. As mentioned, they are not for communication. They're only to indicate that something is wrong in the network or in your device's NIC chip. Okay. They're only for troubleshooting, I would say. Okay. Cannot be used for communication in any way. Okay. Any questions, any doubts up to this point? There's one more concept called CIDR, but this I'll be explaining this in the upcoming sessions when we talk about Linux commands. Okay. So you can ignore this for now. This is the last concept actually. I'm going to leave this out for the Linux commands class. It's important there. Okay. And yeah, this concludes the entire networking fundamentals prerequisite. Very important for cybersecurity because in the upcoming sessions, when we try scanning IP addresses or checking the logs, you see all sorts of IPs there. As soon as you look at an IP, you have to figure out what kind of an IP is it, which class it belongs to, whether it's public or private IP, etc., etc. Because from that, you can figure out where the attack is being initiated from. If it's a private IP, it means the attack is in the local network. Attacker and you are in the same network. If it's a public IP, it means the attack is coming from the internet. Okay. So to identify all those IP addresses, which IP belongs to which class, which category, you need to know all these concepts. Okay. So that is why networking is a very important field for cybersecurity. And that's the reason why we have been taking up these classes before cybersec. Okay. In the next class, we'll be talking about the practical lab setup. how do you install this application called VMware? And in this VMware application, how do you install the Kali Linux operating system is what we cover in the next topic. Okay. So this is the practical lab setup installation required, guys. I'm going to show you how to install this lab in the next class. Okay. I'll be sharing all these softwares with you. How, again, the VMware workstation software, the Kali operating system and all. So tomorrow it's going to be a practical session on how to install the lab simulation. Okay. And this is the simulation we'll be working on throughout our entire course. Okay. So a very important session, I would say. Please do join without fail. Okay. So yeah, that's that. Nothing further for the session today. Any questions or doubts up to this point?
No, sure. Thank you.
Right. Okay. Take care, guys. See you tomorrow at the same time. Bye bye. Have a good day.
Yeah, thank you, sir.
Thank you, guys. Bye.